So welcome to another session of Everyday Mathematics. Today we look at the MIT Integration by Qualifying Exams 2012, problem number 4, which is the indefinite integral of 1 over the square root of x times, open brackets, the fourth root of x plus 1 to the power 10. So this is an interesting problem. Let's see how we could as well solve it. So this is our problem, right? The indefinite integral of 1 over square root of x, open brackets, fourth root of x plus 1 to the power 10. As we always say, we look for the most intricate expression, and how I see here is this is the most intricate one. And with that, I would like to just substitute uh, that with u. So I say let u be equal to the fourth root of x. And what that means is that u to the power 4 is equals to x, such that 4 u to the power 3 du dx would be equal to 1. And that's the derivative of x is 1. And so what this means is that 4 u to the power 3 du can be used to substitute for dx. And this will come, we arrive at this by multiplying both sides by dx. So this is a very important expression for us. However, we would like to see one other thing, is that we do have the square root of x, and that means that u squared is the same as the square root of x, and that is square root here, square root here. From this expression here. So our integral now in the u domain becomes, in place of dx, we're going to put 4u cubed du. In place of square root of x, we're going to put u squared. In place of the fourth root of x, we have u plus 1 to the power 10. Right? And so this means that now we have 4u du over u plus 1 to the power 10. So that's an interesting thing we have there. The next thing I would say, okay, since we have a complicated expression here, I don't want to expand u plus 1. I may as well just say let y be equal to u plus 1, such that dy du is equals to 1, and that means that we could just say, multiplying du on both sides, that we can substitute for du with just dy. And so what that means is that as well, y minus 1 equals to u. This is another important piece, because we'd like to substitute off that expression here. Okay, so since our integral is 4 u du over u plus 1 to the power 10, and we substituted off things with y. This is y minus 1 over y to the power 10. In place of du, we have dy here. So as you can see here, the integral becomes a little bit more tractable. So we have 4, and then we have 1 over y to the power 9, dividing this and that, minus 1 over y to the power 10 dy. So as you can see, things are actually very integratable now, and yeah, we'll keep solving that. Since our integral becomes 4, 1 over y to the 9 minus 1 over y to the 10 dy, And this becomes now 4 over 8, and there's a negative here, y to the 8, and negative 4 to the 9 over y to the 9 plus the integration constant. Now this becomes negative a half y to the 8 plus 4 over 9 y to the 9 plus the integration constant. And since we said y equals to u plus 1, that means we're going to substitute where we see y, we'll put u plus 1. So let's continue. Since our integral is negative 1 over 2 y to the 8 plus 4 over 9 y to the 9 plus integration constant, and our substitution was y is equals to u plus 1, right? That means our integral in the u domain is 1 over 2 u plus 1 to the 8 in place of y here, plus 4 over 9 u plus 1 to the 9. See, but also since we said u is equals to the 4th root of x, then it means our original integral, square root of x, 4th root of x plus 1 to the 10, is equals to, where there is u, we're just going to put 4th root of x. So we have 4th root of x plus 1 to the 8 plus 4 over 9 4th root of x plus 1 to the 9 plus the integration constant. And that, ladies and gentlemen, is our answer. So again, thank you so much for being patient with us. Until next time, bye-bye. So let's just maybe simplify it a little bit further. So since we said that our integral 4th root of x plus 1 to the 10 equals to negative a half 4th root of x plus 1 to the 8 plus 4 over 9 4th root of x plus 1 to the 9 plus c. We could just say, okay, we have a common denominator by multiplying these things out, 2 and 9, and then also having 4th root of x plus 1 to the 9, so that when now you divide, this is our LCM, or lowest common multiple, divide this by whatever we have here, we get negative 9 in bracket 4th root of x plus 1. Same thing here, plus 8 plus the integration constant there, which is 18 4th root of x plus 1 to the 9 8 minus 9 in bracket 4th root of x plus 1 plus the integration constant. And that's maybe a more simplified expression. All the same, it's still complicated, but I think it's been simplified a little bit further. But that is how you solve it. Well, until next time, bye bye.